Hi, everyone. Welcome joining us today. A quick introduction of myself. My name is Lily Young. I am Solution Architect at Databricks, based in New York. I mostly focus on data science and machine learning. Before Databricks, previously I was data scientist in the advertising technology industry. I did lots of work on building machine learning models and data product, including attribution models, which we're going to talk today, real-time bidding prediction algorithm, and audience segmentation. Today, I'm excited to share a use case of Delta Lake and machine learning on Databricks with you. The business context for today's discussion is that on advertising, connecting the effectiveness of advertising spends with sales or conversions is very important. Say if you are a marketing analyst or you're working at an agency, you're likely familiar with attribution model, which tie advertising campaigns to your various APIs, for example, sales or conversions. However, a traditional attribution model, for example, marketing mix model, can be a fairly expensive process, especially when you need to, say, collect data from various resources as upstream to build and refresh attribution model against a constantly updating data set. And fortunately, Databricks provides a unified data analytics platform with Delta Lake, which is an open source ASIC transaction layer for your cloud data lake to empower the largest scale data engineering and data science. In this demo, we have two notebooks. We'll walk through an overview of how simple it is to build an end-to-end workflow on Databricks platform, from loading the data, using Spark to do some transformation, using Delta Lake as an optimization layer, creating bronze, silver, gold, 3 stages of the Delta table, and ultimately feeding the data to train a media attribution model and effectively interpret the results as the last step. The data set I use here is the foot traffic data from sales SafeGraph, which aggregates the in-store number of visits. My goal is to use Databricks to read in different online fast food restaurants in-store visit data, explore the data in PySpark and Spark SQL, transform the data into clean, reliable form to make it analytics ready for downstream machine learning tasks. So as an advertiser, I want to find out which of the online media channel are the most effective channel driving in-store visit over New York City fast food restaurant chain. So let's get started. First step is to load the data from the blob storage. So I pre-mount S3 bucket to Databricks file system so that we can directly load the raw CSV file from my blob storage to Databricks. And then here, I create a temp view, which allows me to directly interact with those files using Spark SQL. So this is the raw data table we are using. It looks like the in-store visit here, you can see here, is a big array. So it seems like we have some feature engineering to do later on to do some transformation. And we have region here, city, location, so on and so forth. Then I feel pretty good about this raw data set. It looks not that dirty. We can write out this data set using the Delta format here to create a Delta Lake bronze table to capture all the raw data. The advantage of using Delta Lake format is that it provides extra reliability and tons of performance optimization on top of your Delta table. Here, I create a bronze table pointing to this location so that I can share with my teammates. Once we get the raw data in, we have some cleaning and feature engineering work to do. So, for example, I want to add an additional feature, MSA region, and I want to do some parsing to get the month and year into the data frame. And then I need to explode the array, the big array visit by day, into several rows. So this block of function I just used to flatten the array. After I run this code block, it returns the one data frame visits by day with number of visits mapped into each row. So those are the target variable we're going to use. I'm pretty happy after the feature engineering. So I persist this cleaner data to Delta Lake and as the silver layer, the silver table, so that everyone on the team from the data science can access the data directly and do exploration from their end. At this point, after the silver stage of the Delta table, I'm ready to enrich the dataset with my online campaign media data. So for instance, I have a banner impression, social media, Facebook like, and web landing page visits. I can easily join different streams of data to my original data frame. I also call the Google Trend API to put in the Google Trend keywords index to represent the organic search element. So this data is from Google Trends site. Finally, I produce a data set including the in-store number of visits and the online media data. You can see all the data coming together in this data frame. I can quickly derive insight by just plotting the number visit time series data using the building chart. Looking good here. Finally, at the end of the ETL pipeline, we write out this clean, enriched dataset to Delta Lake and create a goal table on top of it for my downstream machine learning task as the next step. So till now, we've finished the ETL part. We use Databricks to ingest and combine all the raw data. We also further clean, transform, and add actual reliability to the data by writing to Delta Lake for faster query performance. So at this point, I feel pretty good to use Delta Goal Table, and I want to, now it's time to create the attribution model, moving from the ETL upstream to here, the brain part. In this notebook, we're going to create Delta Goal Table, look closely at foot traffic in New York City to understand how the fast food restaurant various advertising campaign efforts drove the in-store visit. So the goal of this workflow is, one, to create machine learning approach that, given we have a set of online media data, we want to predict the in-store number of visits. And second, once we have the model, we want to leverage sharp model interpreter to decompose the model prediction and quantify how much of our KPIs were driven by a certain media channel. Okay, so the first few steps is one, to load the saved conda environment for this machine learning task, and very similarly, to read in the data by creating a data set pointing to the foot traffic goal table. Then, as a data scientist, I want to quickly check the distribution of my target variable y, the number visit, and against the feature. Will they meet the algorithm assumptions, right? So we can quickly identify from this chart, this chart I plot, it include all the New York State data. It seems like there are two peaks here indicating multimodal distribution. This may be due to underlying differences of population in different regions. So when we drill down and separate New York City traffic from all the other cities, the distribution looks close to normal, I would say. New York City must be a unique region here. As a data scientist, I love using pandas. Here, I can quickly convert the Spark data frame to pandas data frame, and to use Plotly lib to plot charts in the notebook to explore my data. So those charts are from Plotly, and you can zoom in and zoom out and drill down to a specific data points to explore the data. So it's quite handy here. So those time series data looks good. This is the Google trend. As you can see, I can easily create all the statistics plots I need without leaving the same Databricks environment. Then we'd like to check the distribution of all the features using QQ plots. So those are the features that I put in, and this is the QQ plots. It looks good, looks quite normally distributed. There is a good bell curve here. So by now, I'm confident that the data is suitable for model training. So let's train a prediction model. For the algorithm choice, I decided to use XGBoost. The data set is not big, so single node training will get things done quickly. However, building attribution model has always been very iterative process, right? Traditionally, statisticians have to run hundreds of models to find one best model, which is not the most efficient way to do modeling. Here, using Databricks, I can leverage Databricks runtime, machine learning runtime, AutoML capacity. We have the hyperopt built-in by specifying the Spark trial here, just one line keywords change here. The tuning job is automatically distributed to find the optimal hyperparameter for the model. So after the hyperparameter, the best set of hyperparameter was found by hyperopt, I only need to fit the model once here in this cell. And then I can use the fitted model to predict New York City subway in-store traffic. So you can see the red lines here are my predictions, and the blue lines here is the actual numbers of visits. It looks like the model actually captured the major trend, but missing a bunch of spikes here and there. It definitely needs some further tweaking later, but it's pretty decent for our quick efforts here. Once we get the prediction model, so one natural question is, how does the model make prediction? How each of the feature actually contribute to this black box? I will say I don't really know inside out what the attributes actually does, but I want to understand how the prediction was made by the training model. In our case, the question became how much each media input contribute to in-store foot traffic. So that's the business context here again. So by directly using Sharp library, which is an open source model interpreter natively integrated with XGBoost, we can quickly derive insights such as what are the most important media channels driving my offline activity. So from this chart, this contribution chart, it looks like the social media and the landing page visit are two major driving force. This chart you can directly derive from the Shapley library by calculating the Shapley value. And it looks like each of the social media drive 55%, and the landing page was driving 32%. Sharp can provide very granular insight for marketing mix contribution at the individual level. So here on this component chart, we can see how each media effort positively or even negatively a little bit impacts on one day in-store number of visits. Finally, we can create a full composition chart for 1 year daily foot traffic time series. And this chart gives us a full picture of how the in-store visit attributes to each online media input. So from here, can again drill in and take a deep dive. We can make recommendation to the business executive or your agency clients how to do future campaign optimization on their media spend. So with this, it concludes today's demo. Thank you. Recommendation to the business executive or your agency clients how to do future campaign optimization on their media spend. So with this, it concludes today's demo. Thank you.
Okay, thank you for doing that, Layla, and going through our demo here for understanding advertising effectiveness with advanced sales forecasting. For those of you who are joining this session, feel free to type any Q&A into the Q&A panel here, and we're more than happy to take any questions. Okay, thank you for doing that, Layla, and going through our demo here for understanding advertising effectiveness with advanced sales forecasting. For those of you who are joining this session, feel free to type any Q&A into the Q&A panel here, and we'll know you have to take any questions. Again, folks, thanks for joining our session here. If you have any questions, feel free to type them into the Q&A panel, and we will be happy to answer them. So it looks like we do have one question here. This is from Michael at Optum. The question is just wondering if the code notebooks are available. I can take that one. Yes, they are available. Thanks for joining our session here. If you have any yes, Michael, these notebooks are available. They're available on databricks.com/blog. And if you just type in advertising as a keyword, the notebooks, there are two notebooks that are available, one for ETL and one for machine learning that we have available, and more than happy to share those with you after this. Not sure if everyone just heard my my answer to that question though, but there a question from Michael Conley asking if the code notebooks are available. Again, those are available at databricks.com/blog. If you just type in advertising as a keyword, there's a blog that kind of gives you the how-to on this, as well as the available notebooks for ETL and for machine learning that are both available now. All right, folks, if we have any other questions, feel free to type them into the Q&A panel here, and we are more than happy to answer them. We'll give it another minute, and if we don't have any other questions in the next minute or two, we can wrap early. Again, folks, last call. If you have any other questions here around the notebook that Layla just presented on advertising effectiveness with advanced sales forecasting and attribution, feel free to drop them into the Q&A. We'll be here for another couple minutes. All right, folks, last call for any other questions. Otherwise, we will wrap this up. Give it another 30 seconds here. Again, if you have any questions, feel free to put them into the Q&A panel here. Layla, you did such a good and convincing job that all the questions are not there.
Thanks, Steve.
So with that, since we don't have any further questions, again, the best way if you're looking for more information on the notebook that Layla provided, if you go to databricks.com/blog, and then in the keyword search, just type in advertising. This should be one of the first things that pops up. Layla authored an amazing blog and also built these notebooks both for ETL and machine learning aligned to this use case. They are publicly available. Would love if you're interested to import them into your own environment and take these notebooks for a spin. So with that, thank you all for joining us today, and thanks, Layla, for presenting the amazing work you did on this use case.
Thanks, everyone.
Thanks for joining all.